All right, we're back. We are now on page 6 of notes 5 for Calc AB. It's about the mean value theorem. So we're just doing, we did a bunch of traditional problems. Now things are going to get a little more interesting, I think, when we get to deal with table problems, which are what I think of really when I think of using the mean value theorem. So let's see first what this problem is asking us to do. Having a lot of trouble talking here. All right, so problem. Given f of x equals x cubed plus 3x squared minus 5. Use your calculator. Excellent. To find a value of b. To find a value, b. There should be a comma there. Let's edit that. Comma, b. Correct to 3 decimal places such that x equals 3.2 is the value guaranteed by the mean value theorem on the interval from 2 to b. So this is interesting. Show your setup. Use a calculator to create a graph of the function, the secant line, and the tangent line. Functions. Okay, we can do that. Let's see. So if we're going to use the mean value theorem, we should really say that we're allowed to use the mean value theorem. So I'm going to do that mostly for practice. I mean, I don't think you need necessarily to do it here, but I'm going to say f of x is continuous. Well, I'm going to say f of x is differentiable. There we go. First time we just busted that out. Differentiable, which implies continuous. All right, so mean value theorem applies. Mean value theorem applies. Okay, so what is this problem saying? This is not a standard mean value theorem problem. We already know the value of c. c is equal to 3.2. So this value that we're given here, that is the value guaranteed by the mean value theorem. So that's c. So what we're trying to do is our interval is what? Our interval is from 2 to b. So b has to be bigger than 2. And b can't be 2 because that wouldn't give us an interval. And if b is less than 2, then the interval wouldn't be from 2 to b, it'd be from b to 2. So we're looking for a number bigger than 2 when we do this. All right, so we want to solve f prime of 3.2 is equal to f of b minus f of 2 over b minus 2. All right, and then we need to know what b is. So let's see. Definitely a calculator problem. Here we go, over the calculator. I'm gonna start a new document. I don't know, yeah, I think you can see it. No, I'm gonna start a new problem. Can you see, I'm on document 28. I'm just asking for this calculator to crash on me, which happens on the software, never happens on the handheld. Thank goodness, because I don't know what you would do. So f of x is x cubed plus 3x squared minus 5. All right, so what do we want to do here? I'm just going to find the derivative of f of x at x equals, so at x equals 3.2. A better way to do this, a way that would be better than what I'm doing, let me delete it, is to do menu, option 4, option 2, the variable is x, 3.2, and then just do f of x. So that's faster. I don't know why I don't do it. I mean, I'm not convinced that it's really faster for me to do it by hand that way on the calculator when I'm typing. So 49.92 is actually the value. It's not like hiding decimals on us. So now we want to solve that equation. So menu 3, 1. The answer, so I'm going to do answer, equals f of b minus f of 2 over b minus 2. We want to solve that for b. And we want b to be greater than 2, but I'm just going to like eyeball it when we get it. So b, I'm going to say b is 4.295 because we always go three decimal places correctly rounded. So I'm writing that in the notes. So b is approximately 4.295. 4.295. Okay, so now the reason I stayed here is that we're supposed to use our calculator to like graph this scenario. So I'm going to add a graph page. So graph, and I want to graph f of x for sure. And then I need to graph the tangent line at x equals 3.2. So I know that the tangent line at x equals 3.2 has a slope of 49.92 because that's f prime of 3.2 times x minus 3.2 plus what is the value of the function at 3.2? I'm just going to do f of 3.2. This should give me the tangent line. So it's basically point slope form, right? Y minus y0 equals m quantity x minus x0. So x0 is 3.2. F of 3.2 is the y value, and then 49.92 is what we got for the slope. So that's, let me just checking that. That's crazy big. Let's zoom out a bunch and then maybe zoom box around the interesting part. So menu for box. Nope, not good enough. What the heck? Let's change the window. I'm gonna go to window settings. All right, so 3.2 is where we're interested. Let's go -5 to like 9. And then we'll go -10 to 60. Really not good enough. Let's go negative. I mean, like whatever, it's fine, but we go to 100. Wow. Okay. I mean, that's pretty good. You know what I need to do? Well, let's do the secant line, right? So the secant line, we're gonna do f of. Let's go back here, and I'm gonna store this value. So I'm gonna say BC for the B coordinate, and then I'm gonna store this so I can just like use that. And click over here. So I want the slope is f of the B coordinate minus f of 2 over the B coordinate minus 2. And then x, I'm going to say minus 2, plus the y value at 2, which is f of 2. And this should give me my secant line. Okay, now I have a better idea of what I need to see when I zoom. So let's zoom out. I feel like zoom has such a different context in my life now than it used to. It always used to mean like to make a graph look the way you want it to. Now it means kind of to hold class, basically. All right, there we go. That's a good looking picture. So we have our tangent line at x equals 3.2 is parallel to the secant line that we found on the interval from 2 to the B coordinate that we found. The B coordinate was whatever it was, 4.295. So it worked out. It looks really nice. I'm gonna go back to the notes, and then I think I'm probably actually just gonna stop this here and come back in the next video and do a little bit more of these. So we set it up, we use a calculator extensively, so if you're not sure, maybe take some notes on what we did on the calculator if that's something that you think you will need to refer back to. Otherwise, if you're like super good at the calculator, that's a great skill to have because we're gonna be doing it a lot. All right, I'll be back in the next video to do a little bit more of these, and I will see you then.